Hello there. Somewhere, something incredible is waiting to be known. This is a famous quote by an American astronomer, Carl Sagan. Yes, we all know how wide is our space. It is unimaginable. I and my colleagues are here to take you into the space. Let's travel. We humans have always been an explorers. When ancient humans stumbled across unknown lands or seas, they were compelled to explore them. They were driven by a desire to dare and conquer new frontiers and by a thirst for knowledge, wealth, and justice. These are the same motivations that drove people of the 20th century to venture into the space. Cosmology is a branch of astronomy that involves the origin and evolution of universe from the Big Bang to today and on into the future. Introduction to James Webb Telescope. The James Webb Space Telescope (JWST) is a space telescope which conducts infrared astronomy. As the largest optical telescope in space, its high resolution and sensitivity allow it to view objects too old, distant, or faint for the Hubble Space Telescope. This will enable investigations across many fields of astronomy and cosmology, such as observations of the first stars, the formation of first galaxies, and the detailed atmospheric characterization of potentially habitable exoplanets. The James Webb Telescope was launched on 25 December 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first JWST image was released to the public through a press conference on 11 July 2022. Initial designs for the telescope, then named the Next Generation Space Telescope, began in 1996. Two concept studies were commissioned in 1999 for a potential launch in 2007 and an $1 billion budget. The program was plagued with enormous cost overruns and delays. A major redesign in 2005 led to the current approach, with construction completed in 2016 at a total cost of $10 billion. The high stakes nature of the launch and the telescope's complexity were remarked upon by the media, scientists, and engineers.
From the dawn of humankind to mere 400 years ago, all that we knew about our universe came to the observation with the naked eye. When Galileo turned his telescope toward the heaven in 1610, the world was in for an awakening. Saturn, we learned, had rings, Jupiter had moons. The nebulous patch across the center of the sky, called Milky Way galaxy, was not a cloud but a collection of countless stars. Within but few years ago, our notion of the natural world would be forever changed. A scientific and societal revolution quickly ensued. In the centuries that followed, telescopes grew in size and complexity and, of course, power. They were placed far from city lights and as far above the haze of the atmosphere as possible. Edwin Hubble, for whom the Hubble telescope is named, used the largest telescope of his day in 1920 at Mount Wilson Observatory near Pasadena, California, to discover galaxies beyond our own. Hubble, the observatory, is the major optical telescope to be placed in space, the ultimate mountaintop. Above the distortion of the atmosphere, far above rain clouds and light pollution, Hubble has an unobstructed view of the universe. Scientists have used Hubble to observe the most distant stars and galaxies as well as planets in our solar system. Hubble launches and development in 1990 April marked the most significant advance in astronomy since Galileo's telescope. Thanks to 5 servicing missions, more than 25 years of operation, our view of the universe, our place with it, has never been the same. Did you know Hubble has made more than 1.5 million observations since its mission began in 1990? Astronomers using Hubble data have published more than 19,000 scientific papers, making it one of the most productive scientific instruments ever built. Those papers have been cited in other parts 1.1 million times. Hubble does not travel to stars, planets, or galaxies. It takes pictures of them as it whirls around the Earth at about 17 miles per hour. Hubble has circled Earth and gone more than 4.5 billion miles along a circular low Earth orbit, currently 3.4 or 340 miles in altitude. Hubble has no thrusters. To change angles, it uses Newton's third law by spinning its wheel the opposite direction. It turns at about the speed of a minute hand a clock, taking 15 minutes to turn 90 degrees. Hubble has the pointing accuracy of 0.007 arc seconds, which is like being able to shine a laser beam on President Roosevelt's head on dime about 200 miles away. Outside the haze of our atmosphere, it can see astronomical objects with an angular size of 0.05 arc seconds, which is like seeing a pair of fireflies Tokyo that are less than 10 feet apart from Washington DC due to the combination optics and sensitive detectors with no atmosphere to interface with the light reaching in. Hubble can spot night light on the surface of the moon Earth. Hubble has peered back into the very distant past to location more than 13.4 billion light years from Earth. Hubble generates about 10 terabytes of new data per year. The total archive is currently over 340 TB in size. Hubble weighs about 24,000 pounds at launch, but if returned to Earth today would weigh about 27,000 pounds.
The Integrated Science Instrument Module is a framework that provides electrical power, computing resources, cooling capability, as well as structural stability to the Webb telescope. It is made with bonded graphite epoxy composite attached to underside of Webb's telescope structure. The ISIM holds the 4 science instrument and a guide camera. The NIR cam is an infrared imager with a spectral coverage ranging from the edge of the visible 0.6 micrometer through to the near infrared 5 micrometer. There are 10 sensors, each of 4 megapixels. The NIR cam serves as the observatory wavefront sensor, which is required for wavefront sensing and control activities, used to align and focus the main mirror segments. NIR cam was built by a team led by the University of Arizona, with principal investigator Marcia J. Ricci. The NIR spec performs spectroscopy over the same vectoral range. It was built by the European Space Agency at ESTEC in Nordic Netherlands. The development team includes members from Airbus Defence and Space. The NIR spec designs provides 3 observing modes: a low resolution mode using a prism, an R1000 multi-object mode, and an R2700 integral field unit. Switching of the modes is done by operating a wavelength pre-selection mechanism called the filter wheel assembly and selecting a corresponding dispersive element using the grafting field assembly. Both mechanisms are based on the successful ISO-PHOT wheel mechanism of the Infrared Space Observatory. The multi-object mode relies on a complex micro-shutter mechanism to allow for simultaneous observation of hundreds of individual objects anywhere in the NIR spec of view. There are 2 sensors, each of 4 megapixels. MIRI measures the mid to long infrared wavelengths ranging from 5 to 27 micrometer. It contains both an infrared camera and an imaging spectrometer. MIRI was developed as a collaboration between NASA and consortium of European countries and is led by George Ricci. The Canadian Space Agency also provided a near-infrared imager and slitless spectrograph module for astronomical imaging and spectroscopy in the 0.8 to 5 micrometer wavelength range, led by the principal investigator Dion at the University de Montreal. Although they are referred together as a unit, the NIRISS and FGS serves entirely different purposes, with one being a scientific instrument and the other being a part of observatory infrastructure. NIR cam and MIRI feature starlight blocking chronography for observation of faint objects such as extrasolar planets and circumstellar disks very close to the bright stars. How many light years can the James Webb telescope see? Scientists using the James Webb telescope have imaged the most distant star ever, observed thanks to a ripple in spacetime that create extreme magnification. It's currently 28 billion light years away, and its light have traveled 12.9 billion years into James Webb Telescope's optics. How long did the James Webb Telescope last? The JWST is expected to operate for 5 years after its launch.
This landscape of mountains and valleys speckled with glittering stars is actually the edge of a nearby young star-forming region called NGC 3324 in the Carina Nebula. Captured in infrared light by NASA's new James Webb Telescope, this image reveals for the first time previously invisible areas of star birth, called the cosmic cliffs. Webb's seemingly three-dimensional picture look like craggy mountains on a moonlit evening. In reality, it is the edge of the giant gaseous cavity within NGC 3324, and the tallest peaks in this image are about 7 light years high. The most powerful and significant space telescope, James Webb Telescope, has captured the iconic pillars of creation. It comprises enormous structures of gases and dust forming with stars. First shot on a statement released on Wednesday, the United States Space Agency stated that the James Webb Telescope has captured its first image of massive copper, gold, and brown columns 6,500 light years away from the Earth, standing within the vast Eagle Nebula. It was in 1995 that NASA's Hubble Space Telescope captured the first images of the pillars. Ejections from stars from the images captured by James Webb Telescope, bright red, lava-like spots can be seen at the ends of several pillars. NASA said these are the ejections from stars. These stars are still forming and are only a few 100,000 years old. It further added that supersonic jets are periodically shot out by these young stars, colliding with material clouds. The science program manager at the STSCI, Klaus Pontoppidan, said on Twitter that they had to do the pillars of creation because of popular demand.
Inside Pillars of Creation. While this image is spectacular, there are actually stars that Hubble can't see inside those pillars of dust. And that's because the visible light emitted by those stars is being obscured by the dust. But what if we use the telescope sensitive to infrared light to look at this nebula? Near infrared view pillars of creation in infrared, the pillars of creation in the Eagle Nebula captured in infrared light by Hubble. The light from young stars being formed pierced the clouds of dust and gas in the infrared. And if Hubble, which is optimized for visible light, can capture a near-infrared image like this, imagine what Webb, which is optimized for near-infrared and 100 times more powerful than Hubble, will do. The dusty cocoons of star and planet formation, Webb's amazing imaging and spectroscopy capabilities will allow us to study stars as they are forming in their dusty cocoons. Additionally, it will able to image disks of heated material around these young stars, which can indicate the beginnings of planetary systems, and study organic molecules that are important for our life to develop. A protostellar cloud will continue to collapse as long as the gravitational binding energy can be eliminated. This excess energy is primarily lost through radiation. However, the collapsing cloud will eventually become opaque to its own radiation, and the energy must be removed through some other means. The dust within the cloud becomes heated to temperatures of 60 to 100 kelvins, and these particles radiate at wavelengths in the far infrared, where the cloud is transparent. Thus, the dust mediates the further collapse of the cloud.
Mission goals. The James Webb Space Telescope has 4 key goals. First one, to search for the light from the first stars and galaxies that formed in the universe after the Big Bang. Second, to study galaxy formation and evolution. Third, to understand star formation and planet formation. And the last, to study the planetary system and their origin of life. These goals can be accomplished more effectively by observation in near-infrared light rather than the light that is visible in the spectrum. For this reason, James Webb Space Telescope will not measure any visible or ultraviolet light like the Hubble telescope, but it will have a great capacity to perform infrared astronomy. James Webb Space Telescope may be sensitive to a range of wavelengths from 0.6 to 28 micrometer, which is corresponding respectively to the orange light and deep infrared radiation at about 100 Kelvin or minus 173 degrees Celsius. James Webb Space Telescope may be used to gather information on the dimming star of light KIC 864528. It will be able to tell if an exoplanet has methane in its atmosphere, allowing the astronomers to determine whether or not the methane is a biosignature. Lights out on the James Webb Space Telescope. What happens when the lights are turned out in the enormous clean room that currently houses NASA's James Webb Space Telescope? The technicians who are inspecting the telescope and its expansive golden mirrors look like the ghostly brides in this image, as they conduct a light out, light in inspection in the spacecraft system development and integration facility at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The clean room lights were turned off to inspect the telescope after it experienced vibration and acoustic testing. The contamination control engineer used a bright flashlight and special ultraviolet flashlight to inspect for contamination because it is easier to find it in the dark. NASA's photographer Chris Gunn said that the people have a ghostly appearance because it's long exposure. He left the camera shutter open for a long than the normal time so the movement of the technician appears blur. He also used a special light painting technique to light up the primary mirror. The James Webb Space Telescope is the scientific successor of NASA's Hubble Space Telescope. It is the most powerful telescope ever built. Webb. It is an international project led by NASA with its partners, European Space Agency and the Canadian Space Agency.
Spiral and elliptical. Telescopes like the Hubble have captured many beautiful images of majestic spiral galaxies, like this one, which is called NGC3344. But galaxies have not always looked this way. The grand spirals we are so familiar with were formed over the course of billions of years by several different processes, including the collisions of smaller galaxies. Giant elliptical galaxies are thought to also be formed by the processes of similar-sized galaxies colliding, disrupting each other and merging. In fact, it is thought that nearly all massive galaxies have undergone at least one major merger since the universe was 6 billion years old. How do the oldest galaxies differ? When we look at very distant galaxies, we see a completely different picture. Many of these galaxies tend to be small and clumpy, often with a lot of star formation occurring in the massive nodes. The question of how these clumpy galaxies evolve and develop structure over time is a big open question in astronomy, and James Webb Space Telescope will help astronomers to learn more. We now know that extremely large black holes live at centers of most galaxies, but what is the nature of the relationship between the black holes and the galaxies that host them? There is also more to understand about mechanisms that cause star formation, whether it happens internal to a galaxy or because of an interaction with another galaxy or merger. One thing we do know is that galaxies are still forming and assembling today.
James Webb and Space Telescope operates in a halo orbit circling around a point in space known as the Sun-Earth L2 Lagrange point, approximately 150,000 km beyond Earth's orbit around the Sun. Its actual position varies between 250,000 and 832,000 from L2 as its orbiter, keeping it out of both Earth and Moon's shadow. By way of comparison, Hubble's orbit 550 km above Earth's surface and Moon is roughly 4 lakh km from Earth. Object near the Sun, Earth's L2 point, can orbit the Sun synchronously with an Earth's, allowing the telescope to remain at a roughly constant distance with continuous orient of its sunshine and equipment bus towards Earth, Sun and Moon. Combining with these shadow avoiding orbit, the telescope can simultaneously block incoming heat and and light from all three of these bodies and can avoid even the small changes of temperature from Earth and Moon's shadow that affect the entire structure, yet still remains uninterrupted solar power and Earth's communication on its sun-facing side. This arrangement keeps the temperature of spacecraft constant and below 15 Kelvin necessary for faint infrared observation. Why is Webb an infrared telescope? By viewing the universe at infrared wavelength with such sensitivity, Webb will show us things never been seen before by any other telescope. For example, it is only at infrared wavelength that we can see the first star and galaxy forming after Big Bang 4. Will Webb take amazing pictures like Hubble? Can Webb see visible light? Yes. Webb will take amazing picture. We are going to be looking at things we have never seen before and looking at things we have seen before in completely a new way. The beauty and quality of astronomical range depends upon two things. One is a sharpness and another one is the number of pixels in a camera. About both of these codes, Webb is very similar to in and many ways it can be better than an Hubble.
It shows the evolution of universe over time in its many layers, and it represents a huge improvement over the capabilities of Hubble Space Telescope, which until the launch of Webb was the largest observatory in space. The telescope will provide scientific data to enable another generation of scientists just starting their graduate work. Webb's discoveries and the audaciousness of its technology will excite yet another generation by demonstrating the wonders created by work in STEM. The James Webb Telescope was hugely expensive, a massively ambitious engineering project, and as proven by this week's first light images, a complete success. It's now a blueprint for all future space telescopes, all of which will be even bigger and better. Thank you.
Equipped his five senses, man explores the universe around him and calls the adventure science. The history of astronomy is a history of receding horizons. With increased distance, our knowledge fades and fades rapidly. By Edwin Hubble.